Okay, so in the last lesson, we learned the basics of the normal distribution and how to apply that 68, 95, 99.7 rule you guys would have learned about back in Algebra 2 with me. In this lesson, we begin to learn a method for finding the area for any value, not only ones that are exactly a certain number of standard deviations away. So let's get to it. All right, so first off, when we talk about the normal distribution, we will distinguish between just a normal distribution and the standard normal distribution. So the standard normal distribution has the symbol z. So we use z for standard normal, and it's a normal distribution with a mean of 0 and a standard deviation of 1. So when we standardize our data, there was a problem like this a couple of videos back. When you standardize your data, you make it so the mean is 0 and the standard deviation is 1. And then based on that normal distribution, so again, that would be a normal distribution with a center at 0 and standard deviation 1, we basically have a table that somebody created that has all the possible areas you could want. This is a small snippet of the table right here, but I'll show you guys how to actually use it by pulling up the table that you guys have in your notes section. So you guys should already have a copy of the table I'm about to show you. But I want to point out before we actually go ahead and talk about this, that the tick marks on the bottom of the axis right here, I mentioned this in the last video, but when you have a standard normal with mean 0, standard deviation 1, every tick mark or whatever value you are on this axis is your actual z-score. So if we know your z-score, we can very easily calculate what percent of values are between or less than or whatever yours. Okay, so for example, they just calculated here the probability that the z-score of a value is below 0.81. So if you look, 0.81 is right here. This green part is about 79% of the area. But how do you actually do that? Well, what you're going to do is pull up the table that you guys already have right here. And this is the very first page. The table that they give you is a left tail probability. You can see that because it has the left part shaded. If you keep on scrolling, sometimes there's pages that have it on the right. So you just have to pay attention to what is shaded. It's like a little key for you right there. And then the way that this table works is you need to figure out the z-score of the value that you care about. So it starts off the z-score right here, like negative 3.4, and then it gives you your next decimal spot up here along the top. So you kind of have to match those two things and figure out where they meet. So for example, if I wanted a z-score of negative 2.43, I would go to negative 2.4, and I would follow it along to the 3 for that. So this would be negative 2.43 right here. First decimal spot, and then they have the second decimal spot that goes with it, and you just figure out where those two things meet. So it's really not too bad to use the table. These all have negative values because they're on the left side of the picture. If you keep on going and scrolling here, eventually you're going to get to the positive z-scores as well in the table. And notice now it's still the area from the left side, but it has the z-score on the right side of the picture because it's a positive z-score instead of a negative one. So using this picture is really not so bad, and I'll show you how it works through a handful of problems. By the way, the name of that table, it's referenced right here, is Table A. So the first problem says find the proportion of observations from the standard normal distribution that are less than 0.54. So in other words, what they're asking us to do on this problem is find the probability that a z-score for a value is less than 0.54. So what I'm going to do is I'm going to use my table right here. I'm going to look it up, and I'm going to go to the positive part and find 0.5 and scroll over until the 4 that goes with it. That corresponds to this number right here, 0.7054. That's the area to the left of a 0.54 z-score, 0.7054. So I'm going to write that down, and I'm going to show you what that looks like via picture. 0.7054. So if I were to look at a normal distribution, standard normal, mean is 0, standard deviation is 1. So a 0.54 is probably like here. The probability of everything less than that, all of this shaded stuff right here, is going to be 70% of the picture, 70.5%. Okay? So before we were kind of held back by only being able to do the perfect 68, 95, 99.7, but this table will allow us to find the probability for any value, not just one that's on those specific standard deviation marks. Okay? So let's do part B together. Part B says greater than a negative 1.12. So negative 1.12, I'm going to go to my table right here. I'm on the negative side. Negative 1.12 would be right here. So that's 0.1314. I'm going to write that number down, 0.1314. Here's the issue with this problem, 0.1314. So if you think about a normal curve, and drawing a picture is always helpful. When we look at this problem, 0 would still be in the middle. So a negative 1.12 would be like, I don't know, there-ish. This problem, though, says greater than negative 1.12. So that's all of this area right here that we actually want. It doesn't make sense if the whole area is 1. You have to kind of use common sense on these. This is definitely more than half the picture, so it's definitely above a 0.5. This area right here, being 0.1314, just doesn't make any sense. The reason for that is the table always finds the left's probability. So they actually found the probability of this little green guy right here, which is not what I want. So what you would have to do is a simple 1 minus, because the whole area is 1, and you subtract out that left green part right here. And when you do that, that would get you the actual answer. So I believe that's 0.8686, I think. If I subtracted wrong, it's basically that's what you do to get your answer. All right, so the next problem right here, you can feel free to pause me if you want to try these yourself. There's little differences to them, so I'm just going to keep talking here, but it wouldn't be a bad thing to try these out. Next problem is greater than 3.89. And if you look at this table, it doesn't even go to 3.89. In fact, it goes to 3.49, and we're already at 0.9998. So almost 100% of the data, 99.98%. So if you think about it, if 3.4, so if I'm going to draw my normal curve, we get a normal curve going right here. The farthest they bothered going on the table was like 3.4. And from 3.4, the area to the left was already 0.9998. Greater than 3.89, we'd have to go even farther right here. And we're looking to the right because we want something even greater than that. So this area from 3.4 is already 0.0002. It's going to be even smaller than that. In a normal distribution, almost all values fall within 3 standard deviations of the mean. 3.8 is really far away from the mean. That does not happen very often at all. So what you can do when it's a crazy low decimal like this, like not even on the table, is just do a squiggly equals 0. It's such a low probability that it's basically 0 for your answer. Okay? So the next one, between 0.49 and 1.82. Again, always get in the habit of sketching a picture. It's just a good idea. 0.49 is going to be a little past 0 here in the middle. And then 1.82 might be like there. So you can look at even my bad picture and be like, well, my answer is definitely going to be something less than a 0.5. More than 0.5 or less than 0.5 is something you should always ask yourself. What you need to do in this situation is look up both of those numbers in the table separately. A 0.49 is going to be 0.6879. 6879. So let me write that down. So 0.6879. That's the area from this line right here and everything less than that. So all this blue part right here is 0.6879. Then I'm going to get my second number, which is 1.82. And 1.82 is 0.9656. 9656. So I'll switch colors for that. 0.9656. So from this mark, everything to the left is 0.9656. So if you use kind of common sense right here and just think it through, everything red is for the second mark. Everything blue is for the first mark. All I ever wanted in the first place was this part right here in between these. So this is going to be the red only part. All I would need to do is subtract my two values, 0.9656 minus 0.6879. And if you just subtract those, you're going to get your answer. So feel free to do that, and then you can go ahead and try out the last one for yourself as I type this in. So 0.9656 minus 0.6879 is about 0.2777. When you do these kinds of problems, please make sure you show your work. The AP test is very big on showing work and not just giving an answer with no supporting details. So that would be the answer for this one. Look up both separately and then just subtract them to get the answer. The last one on here says within 1.5 standard deviations of the mean. So all you would do for this problem here, within 1.5 standard deviations, the number of standard deviations is literally your z-score. So they want to know, that's 1.5 standard deviations, right? That's 1.5 standard deviations left. You're going to look up the z-score for this guy, 1.5. You're going to look up the z-score for the second guy, negative 1.5, and subtract those two values. Just like basically do this one exactly like I did on part D. I don't have the answer for that handy, but you guys should be able to look it up. I guess I can really quickly. So it's 1.5, which is 0.9332. And then you would subtract out the one for a negative 1.5, which is 0.0668. And it looks like it's about 0.8664 for that answer there, 0.8664. So that sort of makes sense. It should make a decent amount of sense here if you think it through. One standard deviation away is 68%. Two standard deviations away is 95%. But it's a little closer to the 95 because the part like right here, this part of my picture is bigger than the extra part I'd get right here if I went all the way to -2. So it's reasonable that that answer is correct. So yeah, using the normal table is not bad at all. Sometimes they can make you use the normal table in reverse. So this time, they are telling you that there's a distribution of scores. A lot of test scores are kind of forced to follow a normal distribution here. And this guy, Joe, scores in the 85th percentile. How many standard deviations above the mean did he score? So we've got our normal distribution right here. Normal distribution for the normally distributed scores. And we know that they scored in the 85th percentile. So recall what that means. That tells us that the area to the left is 0.85. Because the percentile is the percent of scores you are greater than or equal to. So all of these people in blue are less than or equal to you. They say, how many standard deviations above the mean did he score? That's literally what a z-score is. So they're just doing the problem backwards here, and they're asking you, what is the z-score? So the way you do this, when we want to know the z-score, but you know the area, is instead of looking on the edges, because we don't know the z-score, you're going to look at the area, which is all these numbers in the middle of our table. And I'm going to keep on scrolling here. It's obviously going to be in the bigger part, the second half of the table. And I'm going to go to the closest thing I can find to 85%. So that's going to be right here at this cursor, where I have the cursor right now. If you want to go like in between those, you could even average them. This is 1.03, this is 1.04. So you can call it 1.04, or you can go like 1.035 and go in between them. Either of those is acceptable. I'm just going to call it a 1.04 for this z-score here. So this is going to be they say how many standard deviations? 1.04 standard deviations, because that's what your z-score is. All right, in a standard normal distribution, what is the z-score of the first quartile? This also not that bad. The z-score of the first quartile is going to be somewhere over here where the area is just a 0.25. So you can do the same thing looking it up in the table. You guys can pause me and try it if you like. 25%, because that's what first quartile means, appears to occur between these two values right here. So negative 0.67, negative 0.68. I'm going to be fancier on this one, and I'll just average those, go in between them. It's about negative 0.675 is what I'm going to call it. Z equals negative 0.675. Interpret this z-score. A person who scored in the 25th percentile or in the first quartile is 0.675 standard deviations below the mean. I'm not going to write out a full fancy interpretation, but that's what a z-score tells you. How many standard deviations above or below the mean are you? And if you have a negative z-score, you are below the mean. So yeah, that's how you use the table. Now I need to talk about how we can apply this table to word problems. And in order to do that, we're going to have to remember the z-score formula that we learned about earlier on in this chapter. First of all, this is a notation up here that I haven't mentioned yet that's kind of handy. When you have a normal distribution, you're allowed to go n, capital N for normal. And then if I wanted to, like on this problem that I'm going to do in a minute down here, the mean is 32 and the standard deviation is 8. So it's like a shorthand here. N 32, 8 means it's a normal. The mean is 32. The standard deviation is 8. So you'll see that notation right there. When we do standard normal, the mean is 0 and the standard deviation is 1. So this is just a shorthand notation you can use or not use. So anyway, we've got ourselves our z-score formula right here. The number of accidents on a highway is normally distributed, mean of 32, standard deviation of 8. Next month, the highway has 22 accidents. What is the z-score? Here's the issue with our table. Our table is built under the assumption that the mean is 0 and the standard deviation is 1. You couldn't have a table for every random, like, oh, let me bust out my special table that I only use when the mean is 32 and the standard deviation is 8. That's not reasonable to have infinite tables here for each possibility. So this is the standard normal table, mean 0, standard deviation 1. Before we are allowed to use this table, we have to take the information from the problem and figure out the z-score. We have to standardize it using our nice formula we learned about earlier. So in this month, there were 22 accidents. So this problem's x value is at 22. That's what happened and what we're looking for. We subtract the mean. So the mean is going to be 32 accidents. And then we're going to divide that by the standard deviation of 8. This is just how you find a z-score. If you do this, this is going to be negative 10 over 8, which is negative 1.25. This is the z-score for that value. So you can take a value, you can figure out a z-score for it, and then I can even go one step further if I wanted to, and I could look up that z-score, negative 1.25, in my table. It's like 10% or 10.56%. So what would that say? This month is about in the 10th percentile for the number of accidents. It's a lot less accidents than usual. This month is only higher, greater than or equal to 10% of months. Okay? So once you know how to convert it to a z-score, you can use that information to analyze percentages in any sort of problem you want to with these. Now, when you're working out one of these problems here, there's a series of steps here that you use to draw out like the work that the AP test wants to see to give you full credit here. And you can read through these on your own time, but I'm just going to walk you through in an example what that would look like. So, in this tennis tournament, Rafael Nadal, a very famous tennis player, has an average serve speed of 115 miles per hour, pretty fast, and the standard deviation is 6 miles per hour. So this is just his serve speed right here. On average, he hits at 115 miles per hour with a standard deviation of 6. About what percentage of his first serves would you expect to be slower than 103 miles per hour? So we know that his scores, or it should say in the problem, his scores are assumed to be normal. As soon as you see that, you need to sketch a picture. I want to see a picture for every normal distribution problem you do. It's a good way to show your work, and it will also stop you from making some silly mistakes. So the mean in my problem right here, the mean for his serves is 115. So I'd put mean is 115. The standard deviation is 6. And what I'm going to do to mark the standard deviation in the picture, I don't want to put all my tick marks like I would in a 6895 type problem. I'm going to go from the middle right here to about where that inflection point is, and I'm just going to label that. So the standard deviation is 6 miles per hour. And then what else I need to put in the problem is what they actually ask me to find. They ask about 103 miles per hour. That's kind of my x value. That's clearly going to be less than a 115, and it's less than 115 minus 6. So it's somewhere over here. So my 103 is going to go right there. I care about slower than 103. So I am looking for, in this problem, the area of this piece right here. Area equals question mark. It's also a really good idea when you do these to write context on the bottom of your graph. So this is Nadal's serve speed. AP problems can be kind of picky about giving context and showing enough work. By labeling this whole picture right here, you're doing a lot of the work that they require. You're showing it's normal, you're showing that what the mean is, you're showing standard deviation, you're giving context, and you're marking this part right here. So if I come back and get an answer, oh, it's 70%, I'm probably wrong because this is a little part of my picture, clearly less than half. So time to actually answer the problem. Now, in order to do that, I need a z-score first because I need to be able to use my table. So the first thing I do is I calculate my z-score. I would take the 103, my value, minus the mean. I would divide by my standard deviation, which in this problem is 6. If you actually calculate that, you're going to get a clean -2 right here. Then I got to say what I'm doing, and I'm going to use table A. The probability that my z-score is less than -2, which is what I just got right here. Now I got to look it up in my table. So -2.00 is right here, 0.0228. 0228. So what does that mean? This area right here is about 2% or 2.28% of the picture. So if this is 2.28% of the picture, the last thing I have to do after I show my work right here is I have to answer the question in context. Best way to do that is just to restate what the problem says. Approximately 2.28%, or you can just leave it as a decimal, of Nadal's serves are less than 103 mph. Draw a picture, nicely labeled. Show your work and say how you got your answer. I use the table to get the probability here. Answer the question in the context of the problem. That would be a full credit answer. So let's look at our next one. What proportion of his first serves would you expect to exceed 120 miles per hour? I'm going to reuse some of my space right here. Still have the same mean of 115. Still have the same standard deviation of 6. So I've got standard deviation 6. I've got mu 115. This time I want to know about above a 120. That's 121. So 120 would be like here-ish. And they want to exceed 120. So I'm going to be doing this kind of a probability right here. That is the area that I'm looking for. When you do these problems on the homework or on a quiz, model my solutions that you're seeing right here in the video in terms of how I want you to show me your work. Next thing I do is I find a z-score for the value that I care about. My value is a 120. So I would do 120 minus my mean divided by my standard deviation. That's going to be like a 0.83 if you divide it out. This time, I'm going to use table A still. But table A always does a less than probability. So what I'm going to be finding when I use table A is the probability Z is, I care about greater than 0.83. That means I'm going to go ahead and put a 1 minus. I have to do a 1 minus on whatever I get. So I'm just going to put that now when it's greater than so I don't forget about it. 0.83, I think if you actually find the full decimal, it's 0.83, repeat the 3 repeats, but I guess I don't need that because it's only 2 decimal spots. I get point, nope, that's negative. Also be careful about if you're going to negatives or positives, because that makes a difference. That's why shading the picture is so helpful. Positive 0.83 is 0.7967. 7967. All right, 0.7967. And if you actually subtract those values, you're going to get like 0.2033, I believe. The reason that shading your picture is so helpful, let's say you forgot, and you're just like, oh, I got 0.79, I forgot to do a 1 minus. You could look at your picture and be like, no, that's not 79% of my picture, it's less than half. So drawing a picture will also help you from giving the wrong number and forgetting to do a 1 minus. So I would do the same thing, approximately 20.33%, blah, 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 of his serves exceed 120 miles per hour. And that's a full credit answer. So these problems, after you learn how to do them, are really not that bad or that scary. For the purposes of this video, I'm going to go ahead and pause on this slide right here, and I'm going to come back with answers because I don't want this to run too long. I recommend while I pause, you try these yourself and you get answers for them. You need to practice with that table and get more comfortable with it before you're actually going to be able to use it well. So try these out, and then I will come back in a sec with the answers. All right, so I'm back here with some work on there, but I chose not to put the full answer for a couple of them because I want to talk through some of the trickier things. So you can see, hopefully you've tried these yourself and you can see how it went. The first problem really wasn't bad at all, so that one I'm not going to bother talking much about. You just find z-scores for both, look up the values, subtract them, and you should get an answer. So that one is pretty cut and dry. And I didn't write the context and the picture because we've already done the same problem several times. Same thing with these last two here. I'm more interested in showing you guys the conceptual answer. When you do these yourself, if this was a quiz question, your final thing to do would always be restate the answer in context. So on this next problem here, it said the fastest 30% of his first serves go at least what speed? That is telling us that the biggest area on the right, or the highest points right here, that area is a 0.3. Unfortunately, that's not useful for us when we use our table. We would have to find the area of the rest of it, which is a 0.7. Since we know the area, this is a problem where you would look it up in the table to get the z-score, and we get this for our z-score right here. I'm not going to show you guys the table again because I think you hopefully get the idea. The trouble is we haven't answered the question. We found the z-score for the highest 30% of his serves, but we didn't actually find the speed that they go at. So what you will sometimes have to do in this kind of problem here is actually do a little bit of mini algebra using the z-score formula. So remember, z-score formula goes value minus mean divided by standard deviation. It's on your formula sheet, but it's something you guys do need to memorize. And then what I'm going to do with this is plug in the things I know. The value, I don't know, but I do know my z-score. So I'm going to put my 0.525 equals, that's my z-score. I don't know my value. The mean is the same as it's been all problem, is 115. And the standard deviation is the same as it's been, which is 6. So all I would do right here is a little bit of easy algebra. I would multiply by 6, and then I would add 115 to get x. If you do that and you actually solve for x, you should get the answer 118.15, and that's in miles per hour. So at the end of the day for this question here, about 30%, his fastest 30% of his serves are 118.15 miles per hour or higher. This is the cutoff if you want to be in the fastest 30%. And then we have our last question right here. And on this last question, we bring in a new player. So all that business about the 115 mean is gone. This new player has a standard deviation of 8, and they don't tell us their mean. Instead, they tell us that 20% of the serves go less than 100 miles per hour. So I've got 100, I've got my 20%, and I've got my standard deviation labeled. With a problem like this, what I would do first is I would look up the z-score that goes to that area. If you do that again using your table, you should get a z-score for the 20%. I ended up using negative 0.84. And then it's basically going to be another just kind of algebra plug and chug style problem where you do isolation. We have z. We do know our x value. It's going to be the value in MPH they gave us, which is the 100. because that 100 miles per hour corresponds to 20%, which is this z-score. I don't know the mean, and I do know my standard deviation, which is now 8. And if you do, again, just regular easy algebra on this problem, you should end up getting, I believe it ends up being, if I typed this in right earlier, 106.72. So sometimes you'll have to do little algebra with your z-score formula to get your answer. But again, these problems are not so scary and not so bad after you get the hang of them.